Thermostats. In this presentation, we're going to be looking at the basic types of thermostats, their concept of operation, low voltage versus line voltage thermostats, line voltage relays, and finally, wiring connections. There are two basic forms of thermostats in the HVAC industry. Cooling thermostats, which are normally open, have a mechanism which closes when heat is increased. And in this way, a cooling thermostat is used to control or turn on a cooling appliance when the heat in the area increases. A heating thermostat is normally closed. The mechanism opens when heat is increased. In this way, a heating thermostat is used to turn on a heating appliance when the temperature in the room decreases. A heating thermostat for a combustible fuel type of heating system will usually energize a gas valve, while a cooling thermostat will usually energize a relay coil for some form of an air conditioning or refrigeration system. Thermostats come in two different voltage ratings: line voltage, which are 240 volt rated, and low voltage, which are 24 volt rated. Line voltage thermostats are typically utilized for different types of in-floor heating and baseboard heating applications. The most common type is a single pole. Thermostat will interrupt one of the two hot circuit conductors, be it 240 or 208 volts. There is no offsetting with this type of thermostat, and it's to ensure that individuals do not assume the baseboard heater is safe to work on due to it being in an off position. Since it's only single pole, it means that only one of the two hot conductors is interrupted. This stops the flow of current through the baseboard heater and stops heat from being generated, but it does not isolate the baseboard heater, meaning that this conductor, as well as the heating element, are all energized up to 240 volts. Older thermostats out in industry still exist and are still in use. Some of these older single pole units still have an off position, and they're obviously safe to continue using until failure, in which case we would need to replace them. If given an old, unused single pole thermostat by a customer to install, you must ensure it does not have an off setting. This requirement is found under Section 62. Line voltage thermostats come in two-pole varieties as well. Double pole or two-pole thermostats will have an off setting marked on them, and that's because the thermostat interrupts both of the hot circuit conductors. Since it interrupts both, there is no shock hazard, and it can have an intended off position. Line voltage thermostats are designed primarily for heating applications. Most cannot function as both a heating and a cooling thermostat. When we're wiring line voltage thermostats, typically we're using line current rated systems, which means that the conductors that terminate to the thermostat need to carry the full amount of load electrical current that we would expect flowing through the heater. In residential installations, a two-conductor red and black cable is used because 240 volts is the system voltage. It typically has a red jacket and sometimes referred to as heat-X. It is permissible to use the standard black and white Lumex, however, the white would need to be phase taped in the cable itself. And it should only really be done if the red jacketed cable is unavailable at the time of installation. Low voltage thermostats. They come in two different varieties of digital and mechanical. Low voltage thermostats take any number of different forms in programmable and analog standard form. And a low voltage thermostat will have a different type of connection. We usually use a multi-conductor low voltage cable that's typically 18 gauge or smaller. In basic systems, there may only be need for two conductors. In complicated systems, we might be using upwards of 8 individual control connections between the thermostat and the heating system. The furnace itself provides the 24-volt AC power that the thermostat will utilize to power its display, and the thermostat will then control when the furnace turns on and turns off. The individual conductors are then terminated to a control board in the furnace, where each terminal is identified by a unique letter. The letter identifiers are standard across all manufacturers. Let's look at these connections. They're usually on a control board like we see here, and they have the letters R, W, Y, G, and C. R and C are akin to our 24-volt power supply. If you were to take your multimeter and connect between R and C on the furnace terminal board, you would measure 24 volts. The remaining three terminals have to do with different functions that a standard furnace is capable of: heat, air conditioning, and just simply fan or blowing of the air throughout the home with no heating or cooling. To simplify things, what we could do is take a length of conductor and test the furnace without a thermostat at all. If we were to connect R to the W terminal, what would happen is the furnace would go into a heating cycle. This would be tricking the furnace into thinking that the room that we are supplying is too cold. If instead we were to connect a wire between R and Y, the air conditioning would turn on. And finally, if we were to connect a wire between R and G, the blower fan would turn on. This can be a fun party trick by going to a neighbor's or a friend's home and connecting a wire between R and G and leaving, in which case the blower fan is continually on forever until they phone you to come back and remove the wire. Thermostats will have the exact same terminals and letters as the furnace control strip. Although we don't have to memorize how a thermostat is all put together, this is an example schematically of what happens. We have, in most thermostats, the ability to do heating or cooling, which means we have a normally open and a normally closed section. Sometimes there is a manual setting that goes between heat and cooling. And often there is also a manual switch that allows the user to turn on the fan if they want to simply cycle the air within the room or the house. On the back of most thermostats, we then have the R, W, Y, G, and C connections. On older thermostats, where we have no electrical loading in there, as in there's no display, there's no digital display, there's no programming, then perhaps we only have R, W, Y, and G. The role of the electrician is then to ensure that the thermostat and the furnace are then connected together. Often individuals will utilize the coloring of the different wires inside the low voltage cable in order to align and ensure that they have the correct terminals connected together. R connects to R, W to W, Y to Y, G to G, and finally C to the C terminal on the furnace. And just a few more shots of some of the different types of furnaces and thermostat connections. The thermostat that we see in our schematic control section has the number or the letters rather R and W, because the thermostat for heating would only need to connect between the R power and W, which then connects to the main gas valve. Now, what if you want to use a fancy smart thermostat like the Nest thermostat on the left that's fully programmable, connects through Wi-Fi, and also gives information through your smartphone? What if you wanted to use one of those with your standard line voltage electric baseboard heaters? Well, there's no way for you to really connect 240 volts from the baseboard to that thermostat. So how can we accomplish this task? In this case, you would need to utilize a conversion relay, and that allows us to use a 24-volt thermostat to control a line voltage 240-volt baseboard heater. What is inside such an item is quite a simple device where a small transformer takes the 240 volts and provides 24. The 24 volts goes off to our low voltage thermostat, and the connection back, coming back from the thermostat, operates a control relay coil. The coil, when energized, engages or closes the two power contacts in the 240 volt circuit. In this way, a fancy new low voltage thermostat can be used to operate the older or more basic electric baseboard heaters, which operate at a line voltage of 240 volts. Older analog thermostats have some additional quirky features. When we look at an analog or a standard heating thermostat, low voltage, sometimes the actuation or the operation of the system is through a glass capsule with a puddle of mercury. The capsule is then shifted left to right based on the heat due to a spiral bimetallic strip. When the puddle of mercury flows to the left-hand side here, it actually connects two separate little electrodes, and the metal mercury then completes the electrical circuit. As we can see here, there are a couple of different ways in which this can be assembled. Non-mercury thermostats are by far the more common application and would be purchased nowadays as opposed to a mercury. Analog thermostats also have something referred to as an anticipator. Now, what is an anticipator? Well, an anticipator is a heat generating device inside a thermostat which tricks the thermostat or anticipates when the room set temperature will be reached. In a heating thermostat, the heating anticipator is actually a small wire, which is resistive in nature, and when current flows through it, will generate a wee bit of heat. The small wire that creates heat is actually adjustable. Think of it as an adjustable resistor. And it's adjusted by rotating the metal wiper arm that we see in the picture. The adjustment and the numbers that are referred to match the gas valve current rating. In order to appropriately set this, we need to go down to the furnace, view on the nameplate the amperage current rating for our main gas valve, and adjust this wiper arm to the relative position of current draw. The purpose of having such an item is that it is in series with the gas valve and adjustable, and it makes the thermostat think the room is warmer than it is, and so it stops the furnace early. Now, why would we want to do that? Well, this has to do with the operation of a standard furnace. Remember, when the main gas valve is de-energized, the main blower fan continues to push warm air into the building. And if we were to not have an anticipator, that would mean that the room temperature would exceed the rating on or the setting on the thermostat, which could be uncomfortably warm. In this way, the heat generated by that small anticipator applies to the heating thermostat, and it opens or turns off the gas valve slightly early. A cooling anticipator is a little bit more simplistic in its operation. It is a fixed value of resistance, and again, it's located near the spiral bimetallic. It's a large resistor which heats up again when current passes through it. A cooling anticipator is used in parallel with the relay coil, and it's a fixed value. And this makes the thermostat think the room is warmer than it is, and it starts the cooling earlier. Why would we want this? Again, when a cooling system is first turned on, the instant it's turned on, we do not get cold air blowing. It takes some time for the cooling system to get up to speed and for air that is cold to start blowing through the ducts. units. In this way, a cooling anticipator will make the thermostat feel as though the room is a little bit warmer than it actually is, and start the air conditioning or the cooling cycle earlier.